how microservices are being used in the financial services industry. We have a panel of experts with many years of experience in the industry and also working with microservices and other technologies in and around that space. We have enough brain power here to light up a city. So without further ado, let's get the conversation started. We'll start off with a quick round of introductions of our panelists. We have a global set of panels today, each one of them attending from a different country. So let's get started from time zone specific, let's say. Shubhra, why don't you start with your introduction?
Thank you so much for having us. My name is Shubhra Pandey. I'm a senior solution architect with Synechron, Canada. And I have a career spanning over 15 years, mainly focused on digital innovation in financial domain. Thank you.
Thank you, Shubhra. Tanmay, why don't you go next?
Hey, thanks, Ananta. Welcome, everybody. So my name is Tanmay Chakraborty. I'm based out of Bangalore. I have around 20 years of experience in the IT and work as an enterprise architect in Synechron. I also work as a delivery manager and also manage as a technical solution advisory role for one of the bank based out of APAC, and also represent the cloud practice from APAC. Thank you.
Thank you, Tanmay. Deblina?
Hello, good morning, good afternoon, everyone. My name is Deblina Das. I'm working as a solution architect with Synechron Hong Kong. Currently, I'm on one of Synechron's banking client project. I have around 14 years of experience in product development and software engineering. Past 7.5 years, I'm working around microservices in fintech sector. Today, I'm here with two of my colleagues who have many years of experience in this domain. I'm sure we are going to have a very interesting conversation today. Thank you.
Thanks, Deblina. And last but not least, myself, I'm Ananta. I'm based out of Charlotte, North Carolina. I'm an enterprise architect, also deal with data science and a number of other areas. But in today's conversation, we're going to focus on microservices. So let's get straight to it. Microservices have been around for a number of years now, and as with many technologies, it has its ups and downs and things. So let's get the conversation started about microservices and their relevance in the current world, in the modern world, as we call it. So let's get that portion of the conversation started. Shubhra, why don't you talk a little about that?
Well, definitely. So microservices are definitely relevant, but the real question should be, is microservices worth it for your specific organization or your specific project? And the right answer is maybe not. So for a smaller organization, if you don't have huge team or huge load, it's totally legit to stick with the monolith. So microservices are here for what? Almost a decade. And it has proven itself beneficial and it has got us way forward. And by using microservices, our team can work independently of each other, especially when we talk in terms of speeding up the delivery, time to market, mainly the velocity and isolation. But like any architecture pattern, it had its pitfalls. I have seen a pattern in organization where people believe it's a magic pill that will solve all their problem. But it's not about technology. It's about understanding what your problem is and actually getting to the core of it. It's not just about adopting microservices. I have seen a lot of use cases where microservices were adopted, but the code was not well maintained, automation was not implemented, and in the end, scalability became an issue. So microservices may not be for everyone, not for every use case. A legacy monolith may work perfectly well, and breaking it down may not be worth trouble and effort. So, and frankly, I've seen teams, and there are teams which has moved from microservices and then moved back to monolith, or merged multiple small microservices to a consolidated one. So the architecture we are designing is that of a micro, but the question should be how micro we are talking about. Our target should be minimizing the coordination cost in a complex multi-team environment. If we break up the code into a function in a way that it doesn't lead to minimized coordination, you will end up with the incorrectly sized microservices. So what I'm trying to say, it's truly about understanding what you're trying to solve with that and try to apply some of the best practices. So microservices work, but only where its pattern is relevant. Thanks, Ananta.
Thanks, Shubhra. So you brought up a very interesting point here around microservices being consolidated. Recently, there was an article from Amazon on this topic on their AWS services. Tanmay, do you want to talk a little about what that talk was and how that is relevant to the consolidation or what's happening in the current world?
Yeah, sure, Ananta. So I think there's a lot of buzz that is going around on this, that recently an article been published where Amazon mentioned that they have moved from microservice to monolith. And I think a lot of discussions been happening that there's a now it is happening that a lot of this applications, they are trying to consolidate it and move back from microservice to monolith. Actually, that is, if we try to take a deep down into this particular article, we'll see that that is not the case. So what happened actually, Amazon, they did a refactoring on the microservices that they were operating, and they consolidated few of the microservices into one service, which they mentioned as they have moved from microservice to monolith. So what happened actually, like this is for their Prime Video application, and so initially when they designed, they used serverless and Lambda for designing that Prime Video application. So, and for that they used multiple microservices. But what they didn't actually do impact analysis, that how that particular application will perform when it is put into a high traffic in a high traffic environment. I think that actually happened during the COVID period, like, because lot of most of the people have started watching OTT platform from home, and all these applications has moved into a kind of a situation where they have suddenly put into a kind of a high traffic kind of environment. And that is where they found that the application which they designed with this serverless or this Lambda thing, that is actually taking a lot of performance issue, because a lot of traffic flow is happening across the services. And mainly, like, they are making too many S3 calls from this microservices, and they found their cost is also getting escalated because of this. So what they do, they did a rational thinking on their design perspective, and they consolidated some of these microservices into a single service. And by doing that, they actually have optimized the overall in those internal calls which were happening, and definitely the cost went down for them. So overall, I say, like, it's more of kind of a refactoring approach they had taken. And I think that's a wise approach, probably. And that is exactly what Shubhra means, what she mentioned, right? That means just thinking from the angle that I want to develop microservice because I want to go cloud native, or I need from a legacy modernization, I want to build it. It's not the thing that we should always go through. We should think from a top-down approach and try to understand what will be the best fit for this kind of a scenario. Yeah.
Thanks, Tanmay. Yeah, we kind of see this sort of pattern occur over and over again. Deblina, what has your experiences been in around microservices in their current state?
Yeah, I will absolutely echo what Tanmay suggested. And I think we all should be grateful to AWS for coming forward with this particular case study, which can be a learning lessons for many of us. But if you look back, this is not the first time this has happened. There are many other examples and case studies and articles available online where other organizations, they had faced similar situation. So for example, I can think of one article which came from a data integration service provider company. So they started their journey from monolith to microservice around 2013. So they have a lot of consumers. They created separate microservice for every data consumer. Of course, from the motivation was to create some digital modularity, to have some isolation of deployments. So things were going well, but then around 2017-18, which was their hyper growth period, they were getting new consumers 3 to 4 every month. The number of microservices went up high to 50 plus. The operational cost to maintain so many microservices and create so much orchestration communication channels, that was expensive. On top of that, they had a shared code library, which is used between microservices. And that library required update for certain consumers. They could not update everything in one go for everyone, because that doesn't work that way. So in this situation, what you do, you create a separate version of the library. That is also okay. But when you have too many services, you create so many versions of the shared library that the whole purpose of having a shared library in the first place, that purpose is failed somehow. Because of all these reasons, around in 2018, they decided to go back to a monolithic architecture, and that till date is working perfectly well for them. There is another example of Istio. Istio is one of the market leaders for service mesh. Similar case is there from Istio also. They published a case study. Now, if you look at Istio's architecture from a very high level, there are two parts of it. One is the data plane and one is the control plane. So initially, this control plane, it consisted of 6 to 7 different microservices. But over the period of time, the communication was so complex. Installing this individual component, it became so complex. So they decided to go back to the consolidated microservice or a monolith like Shubhra mentioned. They call it Istio-D now. So there are many such instances. AWS is not the first one and probably not the last one who have done this. And we can just try to avoid it, but it may happen in the future also. What we are trying to say here is that simply based on scalability purpose, just without having a vision of how many services you are going to create in future, how is it going to grow, where are the NFRs going? So that clarity is required. If you have that clarity, then of course, go ahead for microservices. The scalability, the agility, the flexibility it offers, there is no match to it. Yeah. Back to you, Ananta. Yeah.
Thank you, Deblina. Just for all the attendees, if you have questions, please feel free to drop them on the chat. We will get to them towards the end of the conversation. We have dedicated about 30 minutes of time for Q&A in the end. So please feel free to ask your questions there. Thank you. Moving on. So Deblina, you mentioned a very important point around NFRs, non-functional requirements. So from my experience, NFRs have been the greatest driver of change toward or away from microservices. So they affect things in both directions. I just want to take a little time and talk about how your experiences have been from microservices migration on both ends of it. That is going into microservices from a monolith or going to a monolith from microservices. Or hopefully not a monolith, but maybe consolidation of these services and things. So do you guys want to elaborate a little on your experiences in this space? Tanmay, why don't you start?
Yeah, so I think this is a very important phase, like most of the financial institutions are going around. I think to understand that why organization is making a choice on selecting microservices, also we need to understand that what the challenges they are facing right now. So if we try to understand that the challenges that this organization, specifically the banks and the major insurance companies, they first of all, they are trying to compete with the digital native neobank, which are currently operating in the market, right? And at the same time, these banks and they are running on on a legacy based platform. Most of their applications are on the legacy. Now, what is happening there? Their data is also is distributed because there is not much a single source of or a golden source of database that is available. And on top of that, when the digitization started actually 10 years ago, what this bank tried to do, they wanted to put a pretty good they want to match with this bank, and they started to put a wrapper on top of this legacy application, because that is the way they could first come to the market with all this kind of a zazzy outlook that what they want to show to the customer. So what happened at the end is that they have a pretty good front end, but the back end is pretty shocking, right? And that is where lot of performance optimization and those things need to be covered. So now so those are the major challenges. So now what had happened now at this point of time, the bank is actually with a profound technical debt because they have to match with the compliance and the regulatory things. Those are coming from the central banks. They also need to be pretty much secure. on the applications that they are operating. So from that thought process, if we try to understand that what they should do, means what they are trying to think, they also means at the same time they also have a budget constraint, right? Because if we see that 85% of their budget actually they are using for maintaining this legacy application, only 15% probably they are able to use on top of means in modernizing these applications. And for a medium-sized bank, probably there are around 3,000 to 4,000 applications up there. If they try to modernize all of them at the same time, it's a humongous task, right? It's not possible to dive into that kind of. So the bank is now changing their mindset. Okay, now what they're thinking that for the applications which are already there, which are maintaining these products, let them maintain that one in the old application. And whatever the new products I want to launch into the market and which will need all those kind of automations, all those good customer service, even like the AI and the data analytics on top of that kind of a thing. Let's build it on a new applications, which is through a greenfield approach. And definitely those applications which I'll try to build, and those need to be, again, like a cloud native, because most of these banks are operating on multiple clouds. So the thought process definitely comes here that how can I move into that kind of a greenfield strategy if I have to develop new applications. I think the most definite answer is that if you go and build a microservice and which to design this application with microservice, containerize it, and then I can put it on any cloud which I operate. Even like there are multiple cloud options available, AWS, Azure, even the OpenShift, which normally a lot of banks are now using on-premise, that also is operating on Kubernetes platform. So if you start building microservice and containerize it, it's easy to put in a cloud native kind of a architecture, and then you can deploy it in any cloud or any of this platform. So I think that is where the thought process is currently going, that greenfield application, let's try to build on microservices. For the legacy application, stay as it is, means keep it same to run with the old products that is there right now. Yeah.
Thank you, Tanmay. Yeah, we kind of see this sort of a pattern that's repeating in multiple different places. Deblina, what has your experiences been in this case?
Yeah, I'll take a step back and go back to where I started from. So I started my journey on microservice-based architecture around 6-7 years back. Right now, I'm working for a bank, but back then I was in payment orchestration domain. Now, if you talk about payments, it's one domain where API is supposed to be very fast. Once the customer has entered his card details, their OTPs, they are not going to wait for very long. Even when we are making online purchases, we expect the transaction to be done within a few seconds. Now, when we started, we had one single PHP application, which was managing not only the card processing, but a few other value-added services also. So it was working fine. But then the payment industry, it is evolving so much. Every year, we were having a bunch of new payment methods coming in the market and gaining a lot of popularity. For example, there are all these alternate payment options, PayMe, WeChat Pay. In certain countries, in certain regions, some local payment methods, they become very popular. WeChat Pay, Alipay, these are very popular in China. So the customers were coming and they were asking for onboarding, integrating new payment methods within a week's of time. And this single application, it was managing so much. We did not have the ability to quickly do anything. So because there was a lot of regression required, we make a single line of code change and then we are all scared something is going to fail and something is going to fall apart. So that is when we started thinking of how to break down that application into smaller chunks so that we can easily deploy. We can go live with features. The time to go to market will reduce. And the first thing that we kept in mind while doing this migration from monolith to microservice was domain-driven design. So we try to identify things which are part of the main application, but they can be independent services. They have a very explicit business functionality to perform. For an example, when you do a payment transactions, there are certain things which are optional. It may not be required for every transaction, but in some cases, some fraud check is required. Some cases there is currency exchange applied, so you need to talk to the currency exchange provider. This particular application was doing all of that. And it was in a single card transaction. On an average, there are minimum 14 to 15 different parties involved, which means the application is making so many network calls, which is time consuming. So we were sticking to this domain-driven design. We took out one service at a time. We made sure that one particular service, it is performing only one activity. The service for foreign exchange provider, that service is only talking to the FX provider, getting the exchange rate, storing it into its own database, and not anything else. Every single service we created, they had their own database. And the second rule that we followed is, if two services are always talking to each other, let's not break them. Let's not make them separate. So these are the few principles we followed, and I would like to believe we had a very successful migration. Now back to present, I'm in bank now over 6-7 years. Everything has matured a lot. The technology has matured. The thought process, it has changed a lot. When we started, we were doing a lot of things at our own. Like, for example, we created our own data warehouse. We implemented our own analytical platform to represent that data the way customer wanted. Now we are using technologies which are already provided by the cloud. You are using cloud service provider. We are using Google's BigQuery. We are using Google's own data studio for dashboards and presenting the analytical information. So things are evolving a lot, especially in bank. The ecosystem is changing so much. It is expanding so much with mobile banking, open banking. A lot of new subdomains are coming into picture. So I think microservices are not going anywhere. It is there to stay. And that is the pattern I am seeing everywhere, not only in banks, but all these different financial sectors, including payments, including orchestration. So yeah, that has been my journey, and I'm sure it is going to continue. And I'm also going to learn a few new things, and will get a chance to incorporate them. Although in banks, things move a little slower if you compare to other domains because of a lot of security and compliance issues and all that. But yes, it is moving. Yeah.
Right. Yeah, I wouldn't call them issues, or more like requirements,
Yes.
which turn into
Yes.
issues.
Must-haves. Yeah.
Yes. Thank you for that, Deblina. Let's take a moment to talk about the challenges that we're seeing. I saw a few questions talking about the challenges of migrating into or in and around microservices. Let's talk a little about what challenges that you see based on, again, your experiences and what you're seeing happen in your current engagements and so on. Let's start with you, Vibra.
Okay, that's a big one, actually. I will try to keep it short, just to one or two things. So challenge I would like to talk about, let's say, okay, I will pick up a very common one. I have fallen into that trap, and I have seen organizations fall into that trap, and that will be distributed monolithic. So let's say what happened earlier in my career, when I was working with microservices and starting with the microservices, one of, let's say our team decided to migrate to our monolith application to microservices architecture. So we followed the path. We modularized our business logic. We containerized our code base. We built our deployment environment, and we fine-tuned our deployment strategy. But the moment we hit the deploy, problems started popping up. Services were taking too long to start. Failures were cascading from one container to another. And even if we decide to do a small change, we had to redeploy the entire application. So microservices were supposed to solve these problems, but instead it created those issues. And frankly, if this sounds familiar to you, you might have fallen into this very common microservices anti-pattern, that is the distributed monolithic. And it's pretty easy to identify this anti-pattern. Just check if your services has become too chatty, or when you are trying to make a small change, it impacts several other microservices. And or even I have seen one of the common pattern in banks that is happening, that we share a database, and those are the common causes of you will fall into this monolithic, distributed monolith. So once you are in this trap, there's only two efficient ways to solve this. Either live with it or go back to the drawing board. So at the time, the services which we were expecting to grow in a scale, we had to redesign that with additional architecture cost and effort overhead. And the services that were small with no future load increase, no scalability. So we let them be that for that time. And you might make a mistake of trying to optimize this for the short term, but it will end up with really costing us down the road, and really it will start removing a lot of benefits that microservices architecture provides. So be very careful with this anti-pattern. Okay, and the next I would like to talk about is hidden cost. Actually, microservices is a costly affair. So when you add microservices in the mix of your architecture, it adds a lot of moving part to the overall system. And this doesn't come for free. So microservices adoption can lead to cost explosion and performance black holes. And without proper assessment, you risk building something that you can't afford to deploy. And see, cost impact can happen from many issues. So let me give a few of the examples. For example, too many microservices. You started working, you divided your domain, and you're creating too many microservices. Now, since each microservice is hosted independently, the application's cloud cost, I will say, are higher than a more aggregated model of the same code. Or let's say too many deployment options we have today, like cloud providers offer multiple hosting options, such as serverless or managed services. But not all microservices fit each hosting choice. Like, for example, serverless hosting can be expensive if the microservices for your application is running continuously. But if the organization uses internally hosted orchestration and management tools, and especially if it's a multi-cloud deployment, managed services will be hard to justify. So these are a few, but even when something is free, let's say you decide to use service mesh. So how much that wonderful service mesh is going to cost you? And the answer is far more complicated than you might think. Like deployment and operation costs for these service meshes can be hidden. So let me explain. Like for service mesh, if a new sidecar injection impacts more than one CPU in the control plane, costs can quickly escalate, and you add new services because each new service will require individual sidecar. So calculate the number of impact. And if you don't anticipate it, it will impact your budget a lot. And I have seen people miss assessment of services like logging services and Amazon CloudWatch. And if you're running it in the serverless environment, trust me, it's much costly. So apart from the regular cost that we know about, like, okay, you need a huge DevOps team, you need a SWAT team, but we need to think about other cost features too. So assess these tools, features, and cost before setting up your CICD pipeline, building your Kubernetes environment, and even creating your microservices. So I will say the important thing to understand here that what might be the issue for your business is, and weigh it against the benefit. And I truly believe that after the calculation only, if microservices is still best option, then only go ahead with it. Getting a started cost can be higher than monolith, but with the future scale and cost perspective, microservices still is a good option. So these are the few challenges I will like to talk about. I will let my colleagues share some of their challenges. Otherwise, I'll keep on talking. There are a lot we have faced over my career.
Yeah, I don't think there has ever been a lack of challenges when it comes to anything, microservices included. And microservices in particular are quite challenging in that respect. Thank you for that, Shubhra. Tanmay, do you have something that you want to share in that respect?
Yeah, sure. I think Shubhra touched a couple of important points in terms of like when we design microservice, that what are the things we should consider. I think one of the other consideration that comes to my mind is the scalability, right? When we design a lot of these microservices, as soon as we are done, that means we are already isolating these services with their own responsibilities. And when we do that, the situation that comes that some of these services need to scale up when there's a high traffic environment, and some of these services may not be required to be scaled up like the others. For an example, say suppose if we take ITR submission, like a ITR application where we submit our ITRs, if you notice, like the the authentication authorization part, that part is always busy because people are trying to log in. And then there's a site where you submit all the documents. But there are also other part of that applications, like where you will be checking with your last 2 years kind of that, or you want to change your profile on certain things. Those will not be like too much busy, which means that if you break these applications and if you think that all of this based on their bounded context, like microservices are aligned with in the backend, so some of these services will be operating in a high traffic environment and requires definitely to scale out. Okay, during when consumers are accessing these applications, and then the others services may not require to scale out that much. So which means that from the scalability perspective, for this kind of applications, we need to think through that how we want to manage this scalability. One is called a vertical scalability and one is the horizontal scalability. The problem means vertical scalability is easy because you just add the RAM and the CPU and then you basically increase the size of the machine. But there is also another problem because it's a single point of failure. Whereas at the other point, like the horizontal scalability, you're just adding instances. But the other challenge is it's complex because all of this are, if you add multiple like say in the Kubernetes terminology, it's the pods, and then you need to coordinate with them, right? So I think the couple of challenges that normally that comes as part of horizontal scaling is the load balancing, the traffic, then maintaining the consistency because all of these services will be trying to update the database. So consistency, then monitoring and taking the logs, checking whether these pods are healthy or not. So at the end, we are talking about an efficient orchestrator who will be able to manage all of these things, right? And I think what it directs, like if we, again, like from a cloud native perspective, I think Kubernetes is the one of the, I say, like a platform which provides all this, mitigates all these challenges. So definitely if we put a microservice containerized and put it into Kubernetes, I think most of these challenges are mitigated there. And at the same time, I think a lot of this means platforms, cloud platforms, they are all providing different Kubernetes flavor, like AKS for Azure, EKS for AWS, the Google Kubernetes platform. Even in OpenShift also, we have the Kubernetes. So I think that is where, from the scalability perspective, I see that's one of the important NFR that people need to think when they design microservices.
Excellent. Thank you, Tanmay. Deblina, do you have any thoughts that you want to add? Again, like I said, there isn't really, it's a never-ending well.
Yes.
So
yeah. And to Shubhra and Tanmay, I hear you guys, I feel the pain. So you have covered most of the points, but one thing personally, I feel it's one of the very big challenges that banks face when it comes to go to microservices is security and compliance, like I was earlier talking about. So this is a very important area when it comes to banking. Because there are a lot of compliance guidelines which are there on every single service. Now, when you break down one service into 10 different, you are opening 10 different gateways for vulnerability attacks, right? And you need to replicate the same policies everywhere, which could be a very expensive thing to do, and it may be very time consuming as well. And which is why I also see that there are a lot of third parties coming into picture, who are helping banks to make sure that whenever they're moving on cloud, they're helping them to make sure their security, compliance, all these policies that banks, they have to follow, they should follow. So those are maintained. So companies like StackRox, which is acquired by Red Hat by now, and there are many other companies like Datadog and all, they provide this container security to make life a little bit easier when you are planning to go on cloud. Then there is authentication to take care of, authorization to take care of, data security, privacy, data at rest, data at transit. So all those aspects need to be taken care of. And it is not one-time activity. You cannot just create a design and leave it there. It requires review every month periodically. I, as an architect, I spend a lot of time every month. We are having these review cycles where we go through all these points for every application that we are working on. So a lot of cost, a lot of resources go into managing the security compliance guideline. And because the landscape is changing so much, especially with open banking, like I mentioned earlier, this has become very critical now, because you don't want your architecture, the security restrictions to hamper your customer's experience, because customer will expect a seamless experience. But then how do you balance, right? So I guess there are a lot of challenges in this area, but we are constantly working on to strike a balance here. That would be the first thing on top of my mind when it comes to challenges. And the second thing is something I also don't know how to solve. NFR, sometimes the lack of visibility to the NFR itself is a problem. Because if I take an example, I'm working on this reference data hub, which is the bank's internal repository for reference data, which is shared across internal applications. A lot of applications are using it. When we started, the first consumer we went live with, their data files, they consisted of 100 plus records. And we were processing it synchronously and putting the data somewhere. Now the second consumer which came, their data was in millions. And asynchronous API was not being able to process all that and come back within an acceptable response time. So we had to re-architect a little bit. And in this scenario, I would say, because sometimes in banks, especially because applications, the number of applications are too many, sometimes we do not have enough visibility to where the NFRs are going down the line. After a few years, how many consumers are going to be onboarded? What is going to be the data load? I think what can help is to have an asynchronous first approach. Nowadays, that thought process has matured over time. Initially, few years back, everything we used to think was in a synchronous way, but now we are getting used to of that thought process to make it event driven. Whatever is not required real time, make it asynchronous from the beginning only. And that requires a good tracing mechanism also, which I think we are having a lot of focus on managing this distributed tracing, leveraging all the third-party applications, which can manage when you have your applications on multi-cloud. You cannot go for cloud-native solutions. You have to go for something which will work for all these three type of clouds, if you are using 3 clouds. In banks, most of the banks, they are on multi-cloud now. Based on the nature of the application, they choose which cloud provider should this particular application should be deployed on. So with multi-cloud, these challenges come. You cannot go for some technology which works for one and doesn't work for another. So these challenges are there, but I think the skills a few years back, if you look back, and now, if you compare, we have better skills now. We have better understanding of technologies now. So yes, we are reaching there, I would say. Yeah. Back to you, Ananta.
Thank you. Thank you, Deblina. So given all these challenges and your experiences and stuff, what sort of patterns and technology trends that we're seeing to address them? And also, I'm sure some patterns and technology trends are causing some problems, like anti-patterns or the distributed monoliths and things like that we just discussed. Shubhra, do you want to talk a little about the technologies, the patterns, the trends that you see that are playing a role in addressing the problems?
Okay, yeah, definitely. Microservice trends are evolving rapidly, and there's an increase in the adoption of automation, data-driven solution, and even security solution, as Deblina was talking about. So microservices trends like containerization, serverless architecture, and API gateways, they have changed the way applications are currently being deployed, developed, and even managed. Like some of the trends that technology trends I would like to point out will be, use of container and container orchestration tools. They have made it much easier for developers to build, test, and deploy the microservice efficiently. Second one will be serverless architecture, like platforms like AWS Lambda, Google Cloud Function, and even Azure Function. We can deploy our microservices without even worrying about managing the servers. And over the years, I have seen that now organizations are adopting a multi-cloud strategy. No organization these are limited to one specific cloud. So, and the other will be like from enhanced security and communication protocol. If you like to talk about, we have service mesh tools like Istio, Linker, and even Console. But last one and the most important trend personally to me will be in the monitoring and troubleshooting tools. Something like we have Prometheus, Grafana, Jagger, and we can use them for better log management, metrics, and tracing. Now, nowadays, everything in terms of monitoring is automated, including application discovery, agent deployment, and even monitoring configuration across full microservices technology stack. So we have real-time monitoring for the complete micro stack, means no important metrics will be missed, or we won't miss any of the traces, that no wasted time, no blind spot. And it has helped us a lot in maintaining services. And even brought the overall cost of monitoring and troubleshooting down. And having the ability to measure how well our microservices communicate and understanding the performance of connections between the component in our platform, trust me, it's truly one of the most awesome features that we have received. And with all the new technology and trends, it has become much easier to manage the complexity of creating and managing microservices, if I remember my earlier days in my career. So I believe this will give a further push towards the adoption of microservices in the organizations. Yeah, thank you.
Thank you, Shubhra. So continuing on that same conversation around patterns and trends, Deblina, do you have anything that you want to add here?
Yes, I mean, on top of what Shubhra already said, I think CICD is taking a lot of priority right now. So we are constantly working on improving the pipelines we have. Most of the application, we do have CICD pipeline. What we are doing now is enhancing those, adding more automation into it, adding more integration tests, scanning tools, vulnerability scans, security scans, all that. And not all applications are 100% where we would like them to be, but it is a work in progress, and a lot of weightage is given to make it perfect. Now, also a lot of focus is on API management and having standard API documentation. We are using Open API in some places. We are trying to standardize what kind of documentation should be there around the APIs so that it can be used by multiple teams and they can be reused as and when it is required. So automation had always been very important for whenever we talk about microservice. But other than that, I would say with open banking, especially API management, it has become very crucial now. Yeah. Back to you, Ananta. Yeah.
Yeah. Thank you. I was trying to find the unmute button there. Right. Thank you, Deblina. Yes, these points, I mean, they sort of go into more detail. Let's move on to the next, let's say, conversation. Let's talk about. So so far we've talked about what has happened, or what kind of affected microservices in one way or the other. We talked about what problems we see and technology sort of trends that are playing a role in addressing some of these problems. Let's talk a little about what the future holds about microservices and how that, what, let's say, techniques and technologies are being developed, or we see, or you guys see, play a role in it. Shubhra, do you want to get that conversation going?
Oh, so future of microservices. Well, the true answer will be who knows. But if you're talking about next 2 to 3 years, I would like to mention from both cultural and technological shift. So from cultural perspective, I assume some of the organization will see its huge benefit, and some of the organization will end up in a terrible mess, given their reasoning why they went on microservice and how they implemented it. I think we still haven't cracked the stuff around domains and business architecture. Now, this is about business. This is about team structure. It's about focusing how to solve business problem. And there's still maybe too much focus on technology. I think we still need to correct that. And from the technology perspective, I will say technology will continue to grow. AI ops and ML ops will gain more momentum. It will reduce the human intervention in IT operation process. And frankly, by using advanced machine learning technique, it can reduce operational incident and increase the service quality. And trust me, AI ops even can help you predict incident before they happen. For example, such an example will be Amazon DevOps Guru that offers a fully managed AI ops platform service. And it enables developer to improve their application availability and resolve operation issues faster. There will be more technology advancement in terms of communication, CI/CD monitoring, and even troubleshooting perspective, as Deblina was talking about. We aren't there with the terms of CI/CD where we would like to be. And finally, I wish we all could agree that on where the monolithic is applicable, like monolith architecture is applicable, and where microservices is applicable, because clearly they both are applicable. We just have to figure out when and where. Thank you.
Yeah, the bigger problems of life, trying to find out what actually works and what doesn't.
I have a lot of discussion around this topic. No, this one is better, this one is better. And I want to say that, no, both is applicable. Just figure out which one is where.
Right. I'm sure that there are a number of questions that I see which reference in one way or the other about those points. We will get to those questions in about, I guess, 10, 15 minutes, I guess. Let's go to Tanmay to sort of give his perspective on what the future holds for microservices.
Yeah, so I think we discuss on the problem or the challenges that these banks are facing, and they are moving towards legacy modernization, and in most of those greenfield applications they are trying to design with microservices. So definitely microservices is going to be there, because I believe that is one of the way where they can do the modernization. From my own experience, what I've seen, like couple of things that is emerging right now, and what is happening, that a lot of these banks are bringing those AI ML or based COTS product from the market, which is going to give kind of a data metrics and do some data analytics. And we have to design some kind of a integration platform to feed data to this kind of a COTS product. And that is where, like, this integration platforms mainly are built with microservices, event-driven microservices, which are pulling the data from the legacy system, making the canonical payload and feeding this one. That is, and I think these things will going to grow, because if they have to integrate with this to build the integration platform, I think this is one of the best way to do this. The another thing what I see, and I think Synechron had already done a hackathon. So how Gen AI can help in doing the development, help the developer basically to write microservices code. So currently, like when we see that when the microservices are getting productionized, the challenges which these banks are facing at that, the codes are sometimes are not, I will say, like perform savvy. At the same time, they are not very clean. And the other important thing that is also happening, that they need to be also compliant in terms of how many test cases unit test cases we are writing. So in this kind of a agile model where we operate, sometimes that meeting a test case and all these things, this Gen AI based kind of a like tool, which are getting integrated with the ID right now. And we can name few like Copilot, ChatGPT, and definitely the Tab9. So these tools, if developers use them, I think that is what going to help them in terms of writing efficient code, which will be again like performance heavy, and then they can also generate those test cases out of these tools, and which easily they can incorporate as part of their code base. And I think by doing this, their effort, I think the productivity will increase. Okay, so overall, like, this is where the future holds right now. I think this kind of a tool set is going to enhance the overall development of these applications with when we go and develop with microservices. Overall, I think that is where we are heading right now, Ananta. You're in mute.
I'm mute again. Sorry about that. Thank you, Tanmay. This has been a very interesting conversation so far. Lots of interesting ideas and thoughts that we went through. Let's take a minute and jump toward, actually, let's take the rest of the time and jump toward the questions that we have from the audience on this conversation. So let's quickly jump through them. Right, so let's start with the question from Sai Vamsi. He asks, microservices architecture often emphasizes decentralization, decision-making, and autonomous teams. How do financial organizations strike a balance between empowering these teams and ensuring alignment with the overall business goals and strategies?
I can take this one.
Go ahead.
Yeah, so I think it's a very good question. And thanks to you. So organizations, they're going through kind of a change, right? If you remember that when we started from where we started from moving to C++ from normal C language, right? We are mentioning that it was kind of a paradigm shift, right? We were moving to object-oriented kind of a programming. Similarly, here also, like when banks are moving from legacy, trying to do a legacy modernizations, they already have a cloud strategy in mind that they want to move to cloud, and it's not easy for them. And for this, actually, like both the Amazon and Azure, I think they have come out different hours. Where I think Amazon has around 7 hours, where like Azure has around 5 hours, which clearly says like where I need to take a rebuild, refactoring, re-architect kind of an approach for this. So I think it's a difficult choice, but at a high level, I think it means if we start discussing, it will take a long time to discuss and come to a conclusion that what is the right approach to take. But overall, I will say like whenever you touch an application, legacy application, the major challenge is that there is not enough documentation available, right? So if you try to build it, you have to reverse engineer or break it. And for that, it is a time consuming. So overall, if the documentations and you have the knowledge on that one, then definitely breaking that and rebuilding it is the approach that we can take. Otherwise, I will say that whatever the leave that means whatever the legacy application as it is, whatever the new application that you want to build for the new product, you go and build it with a greenfield approach and take that as a approach for towards. Again, the question that can I move mainframe and break it down? No, it's not that easy. I think there is a very, very few cases where it has happened like they have tried to, but mostly the banks are not touching those kind of applications because those are stable and they want to continue, and they want those products until they're sunset. They want to continue with that one. So I think the choice is not that easy actually, but it takes a lot of discussions and thought process to come to a conclusion.
Thank you, Tanmay. I noticed that we have a lot of questions on chat here. If you guys can leave your email addresses, I'm sure the panel would get back to you guys on email or something to respond to your questions. In the meantime, I think we can take a couple of questions before we close. Ved asks, what are the common challenges you faced in monitoring microservices, and which tools would you suggest to use for them? Shubhra, do you want to take that?
Yeah, sure, why not? So when I talk about monitoring, I want to talk in terms of observability. So monitoring is a part of microservices observability. One of the challenges, apart from using which tools to use, when to use, and what to monitor, a common issue that I have seen organizations face is to decide when to start working on the observability and monitoring. So when you start at the microservices or when. So now logically, you should start right at the beginning, but we know that for many of our clients, that's not the reality. So we have accepted that it's just as an iterative process. You can start small and then go big, or start with the basic that you're familiar with and then go through the iterative process till you answer all your monitoring queries. And to me, the main observability concept is that it's to figure out how you gain business insight in application. It's not only just for technological insight, like it's not only for your troubleshooting, but also to understand how business is doing and what your users are doing. Now, I don't want to go to a specific technology, but a good observability tool or monitoring tool should be able to, apart from generating and processing the data, it should have a good storage and fast retrieval and even long-term retention. and also a good visualization layer for your team to consume and take the action. A few of the tools that we are using are Dynatrace and Grafana Labs, or even Honeycomb we are using a lot. Datadog and Signos are also a good option, but I have seen Grafana used heavily, mainly because the number of data sources it support, like Prometheus, Jagger, even AWS CloudWatch. So assess the tool and choose what suits best for your organization, and just go in the iterative process. Start small, then go big.
Thank you, Shubhra. We have another question, the next question from Ravindra. He asks, while getting microservices right is challenging by itself, modernizing an existing application is a beast by itself. With that, what learning would you suggest for someone working on modernization? Deblina, do you want to take that?
Yes, and I would love to take that because I have done one myself, and I know and I agree how challenging it can be, especially if your application is already having live traffic, it is already on production, and you want to upgrade it, you want to create a new microservice on top of it. So there are multiple ways to go about it, depends on the nature of application, how much downtime you can afford, what are your SLAs, all that. But one pattern that I would suggest, which can be very useful, it is called strangler fig pattern. So strangler fig is a type of vine which takes a support from a bigger tree and it grows around it. Eventually it will grow on the roots and the original tree will not be there anymore. Just the structure will remain and the vine will remain. Similar pattern we follow when we are doing brownfield migration. So imagine your legacy application, the old application is the tree, and you have your new microservice, the new application growing. So you will have a facade on top of it, like in gateway. You slowly move your traffic to the new service. And once your new service is stable, you are confident about it, you have already tested with production traffic, then you can demise your legacy application. So it does not need to be a big bang all the time. And of course, you have to be very careful about it. There are many other patterns, but this one is what I can vouch for. I have used it myself. And when it comes to deployment, there are many strategies. You can read about it. We can go for blue-green deployment. There is canary deployment, rolling update deployment. Many of them can ensure zero downtime when you are moving, you are releasing a new service in production. Depends on the budget, cost, optimization, all that. But yes, there are many ways to tackle it.
Right. Thank you, Deblina. I hope that provides you with some insights, Ravindra, to go forward with your modernization, and good luck with the activity there. The next question from Kunal. He says, about 10 years back, we worked on an SOA-based applications. They were monolith in a way because middleware was this big service layer that talked to various consumers. Even though they followed domain-driven design, the individual services were broken down based on a granular, bounded context. So his question is that nowadays we talk very little about SOA. How does this fit into the broad monolith versus microservices discussion? Who wants to take that question?
I can go on that. So there is a little difference in SOA and microservices, and sometimes we tend to confuse a little between them. So when we talk about SOA, the database is not necessarily to be independent. So we are talking only about APIs in SOA. So you can still continue to use a single DB, but your APIs are separate. That is SOA. When we talk about microservice, every single microservice, it needs to be independent. It should have its own database. Like Shubhra was talking about distributed monolith earlier. That is a trap that we tend to fall into. But the basic difference is your microservice should be completely independent, which is not a requirement when we talk about SOA.
Excellent. Thank you for that. Moving on, I think, yeah, we've moved back and forth with the questions. We're trying to order them and sort them. Urmila has a question. How do you think open banking is impacting the architecture based on microservices? Oh, who wants to take that question?
Ananda, can you repeat the question? I couldn't hear.
Right. Yeah, no problem. The question is, how do you think open banking is impacting the architecture based on microservices? Or how do you think open banking is affecting microservices architecture?
Right. I think with open banking, microservice, it has become absolutely necessary now. Now, if you look at open banking architecture at a very, very high level, 10,000 feet view, it is basically your bank is sharing your customers' information with customers' consent to the third-party applications, right? And the purpose can be different. Every application can have their own purpose. These APIs are to expose customers' credit card information or account information to aggregators for different purposes. It can be read-only information for a dashboard kind of application. It can be a write operation for making payments with different apps where your multiple accounts are linked together in a single app. Without microservices, you will not have the agility to have these APIs which are usable, but you can also control them. Authentication becomes a very big challenge here because you don't want to impact customers' experience. You will expect one-click payment, but you need SCA, you need OpenID Connect or OAuth implemented. There are multiple guidelines, PSD2. So open banking is completely changing the landscape, I would say, and making microservice-based architecture absolutely must have.
Thank you for that. The next question is from James. How do you ensure consistency in data integrity across microservices? Also talk a little about the strategies for eventual consistency in a distributed system. Let's take this piece by piece. Let's talk about the how do we ensure consistency in data integrity in a multi-node deployment? Sorry, who?
I think,
Tanmay.
yeah. So I think overall, like when we talk about the data consistency, that when we design with a, we want to address this with a microservice, the way we want to handle how the data is flowing, right? So overall, if you want to containerize and you want to put it in a Kubernetes kind of a thing, right? When data is when we are getting the data into the Kubernetes actually managing from the load balancing perspective, right? In terms of how it is manages the overall interaction between the microservices, and then how the data flow is also going out to the database. So overall, like again, like there are different patterns which we can use as part of this one. Definitely, like overall, using the Kubernetes, I believe you can use that one as part of managing the consistency and this. Yeah.
Thank you. Sorry, I kind of lost the train of thought here. Just bear with me a second. Yes, Shiva asks, how must one go about handling long-running transactions across multiple microservices?
Ananda, can I talk about the eventual consistency? I think
sure.
we skipped on that.
Yes.
So just since the question was asked, like
anyone there
who
were
has
two parts to it, right? I'm sorry, I missed the second part. Yes.
So anyone who has ever done the work as a part of the team, they can understand the power of eventual consistency in the microservices. Now, let's start with understanding that fact multiple people work independently on a specific task, and the best way to complete a complex job, because the overall process doesn't grind to a halt and something doesn't go wrong with one task. So it has to reach to an eventual consistency. So aiming for eventual consistency in a microservices, it's almost the same. Instead of insisting that microservices fire in a specific sequence or either completely fail or complete together, you let them run in parallel at their own speed, which makes sure your architecture doesn't let architecture doesn't let your tasks fall through the cracks. If you have solid scalable architecture in place, you can surely be eventually all the various tasks will be in the consistent state of completion. This is in the stark of what strong consistency is. So microservices operate under the same transaction and either commit or rollback at the same time. So this will be the stark difference, like this is strong consistency, but eventual consistency can take some getting used to, but provided the crucial flexibility in the world where the other application operate or run 24/7. So in real world, the concept of eventual consistency is easier to accommodate and overall resolves the obstacles that we face, that how to go forward with the diverse multi-team environment.
Thank you, Shubhra.
Thanks.
The next question is from Shiba. How must one go about handling long-running transactions across multiple microservices? I think this talks a little about eventual consistency and distributed systems again.
Yeah, I think it is quite connected to what Shubhra explained. So long-running transactions, which means that you have started one transaction, it is calling chain of microservices one after the other. It requires a good distributed tracing mechanism there so that if something fails, you know exactly where to look at. A good logging mechanism is required. You can go with the cloud provided one, or you can use some third party. That does not matter here, but in fact, technology does not matter here. The thought process from the start of the design, it has to be there, that how do I trace it back? Because it is going through so many services. There are many cloud provided technologies, distributed tracing technologies, which can provide exactly that. Using the tracing ID, you can find out exactly where the service was halted or failed.
Right. So this again plays a key role when it comes to reporting and other technologies,
right,
that are central to managing distributed systems. Yeah. Thank you, Deblina. Tanmay, there's a question for you from Sanat. He says, I know you. Hold on, he just moved. Yeah, I know you spoke regarding the NFRs. Is there any other NFRs which are equally important?
Yeah, I think there are a lot of NFRs. I think all of them are equally important, right? In terms of when we go and design and deploy them on production. I think we spoke about like the scalability part. Performance is also one of the important thing. But one of the other important thing which I have seen which is also very, very important is the availability. So availability in the sense like when you put, say again, if you think, I have been speaking more about the Kubernetes because I have worked on this particular area a lot. What I have seen that like when you design and a microservice and you want to put it in production, the availability become a major concern, because if you want to put it only onto us like a one single kind of a node, there's a point that it can fail. So a proper design of a PR and a DR strategy, that is something is very much important. So eventually what happens, like if both should be like in a kind of a active or something active passive kind of a consideration that you need to take. And what happens, like if somehow the DR is down, then you should go to PR. If the PR is down, at least you should be able to move to DR. So availability is one of the I will say one of the biggest thing that when organizations are deploying this on production, they are considering this as one of the major NFR.
Thank you, Tanmay. Next, we have a long question from Ved, but I think I can summarize that. How do you reduce time to market for microservices? The question is around what approaches do you suggest?
See, if your only, okay, yeah, let me take it. So if your only reason that you are considering to move to microservice that you want to reduce your development velocity, and development velocity is not where it needs to be, then you might need to first identify the root cause. What may be your development practices before you're switching to microservices? For example, your test cases may not be automated enough. You don't have proper CICD setup, that these can impact your time to market. So the question should be when to move to microservices. And it's when your development velocity slows down and you're unable to scale independently, unable to have different part of system involved at different times. Okay, so you also have to understand that cost and complexity. Getting a started cost of microservices is much higher than the monolithic. So you see the benefit down the line is not immediate. So you know your domain, you know your boundaries, you know what's going on in those domains. You should be able to reason and make decisions based on these points. So whether you should move to that or not, your approach you follow, please see your development practices first before making a decision to move to microservices. And then based on your business and domain, you can move ahead with it.
Thank you, Shubhra. The next question is from Yasri. I'm sorry, I'm not able to pronounce your name. I'm just going to ask the question. What learning material would you recommend to gain experience outside from the work field? Shubhra.
Yes, yeah, let me take, since when I was starting with microservices journey, I learned a lot of book. I read a lot of books. It's been some time because currently we are on the online resources mainly, reading a lot of documentation, especially when we come to the Netflix and AWS, they have a huge documentation of what they did. And that's a very good learning tools if you want to. And there are courses online available, obviously. If you have Udemy or others, you can go ahead with the course and learn about it. And I will also suggest from the domain perspective and others, there's a blue book by Eric. You should Google it and just look through it. The book is amazing if you have to understand what should be your bounded context, how to define the boundary, how to decide what domain goes where. And so because I believe that microservices mainly tends to be about boundaries and mainly what is the domain a domain is and what each domain works. So unless you have that clear understanding, you won't be able to implement your microservices correctly in the long term and long run. So if you get a time, just read the blue book by Eric. It's awesome. And just refer to all the online resources. I will say there are so many things available. Join these type of panel, join these type of microservices architecture concerts that are happening. But yes, that will help a lot.
Awesome. That was a detailed response. Thank you for that, Shubhra. Next question is from Shwetampari. Getting microservices right is a huge teamwork. How would you explain the role of product owners or BAs plays in the entire journey? What skill set should they possess? Can POs be both functional and techno-functional? This is quite a deeper question. Devlina.
Yes, I would love to answer that. In fact, I keep talking to the BAs and POs in my projects. So it is very, very important for BAs and POs to be aligned with the concept of microservices. And it is important because you are the one sitting between developers, architects, and the customer, the banks. You are the one who understand business. So ask a lot of questions on NFR. Now, functional requirements, we have excellent BAs who are very good at identifying functional requirements which will add business value. Non-functional requirements, sometimes because of the time constraint also, they get a little less priority in the development cycle, and we come to them when we start having performance issues. So ask a lot of questions in the beginning when you are gathering requirement. For example, questions like what is the load of data? If you are talking about file processing, maximum size of the file, what is the peak load? How is this application going to grow in coming years? What is the consumer base? How many people are going to concurrently use this API? What should be the response time of this API? So try to find out these requirements, because this actually impacts, it actually drives how the architecture will be designed. Ask questions like, if you have to notify somebody after a transaction, do we need to notify immediately, or there can be a 1 hour delay? That impacts the architecture, that impacts the design. Things will be designed synchronously or asynchronously. Architect will decide based on your input, which comes from the business. So POs, VAs, they play a major role on how the architecture will be defined, and whether we have to re-architect after a few years or not, that depends. From skills point of view, I will recommend if you can do the foundational courses of any of the Google or AWS or Azure, any cloud solution provider. They have courses, certifications particularly for BAs, POs, this kind of roles, which gives you an overview of all the functionalities they can offer and which functionality can be used for what type of business cases. It will help you to connect the dots, and it will help your architects and designers as well.
I echo with that, Devlina. Frankly, when I was talking earlier, saying that, okay, because microservices architecture is about domain, it's about business architecture. So currently BA and our product owner becomes a crucial part because it is about business. I mean, what is the business problem? How you're going to solve it? So what will be your team structure? And as I told you, there's still too much focus on technology. We need to change it. We need to make it around the business. So BA and product owner plays a crucial part in microservices architecture. And once we understand that, then I think we will end this conversation around microservices is relevant or not, once we understand when and why we are implementing microservice.
Yeah, absolutely. The holistic view is kind of key because if we are pigeonholed into just saying microservices is the way to go and not have that larger picture, that kind of defeats the purpose and leads to a whole lot of problems. And it's kind of, you guys referred to that during your during answering some of the questions.
I heard about an organization where the organization's bonuses were defined on how much microservice they have or how successful they have based on the number of API they have.
We are reaching new heights.
So yes. I want to break that understanding that those type of organizations, they are going to be in a terrible mess in the future if they continue in that pattern. Not everything has to be microservice.
Yeah, it's a near future, not too much to head into the future.
A near future, 2 to 3 years down the road. Or they are already understanding that, okay, they have landed in that mess and they are not trying to claw their way back out of it. So be careful.
Yeah, thank you. The next question comes, let me just get to the question. What's the impact of making application or service highly available in terms of cost? How does it vary from different cloud providers, and how do you choose which is the best way to go?
Yeah, I'll take it. So I think in terms of the cost, like most of the clouds are offering like pay-as-you-go model, right? So yeah, cost is definitely there because if you are trying to maintain two different, if you want to first of all want to make it highly available and you want to provide like deploy this in different availability zones, and then you want to manage the overall traffic through a load balancers. I believe like whenever you are maintaining two different setup Kubernetes clusters and you're trying to do that, and then overall managing the traffic, the cost is definitely going to go high. The only thing is that like there is no easy like solution in terms of like for if I move to this cloud, it will provide me more beneficial like in terms of more or less like across. If you go for Azure or AWS or GCPs, wherever you go, the cost or more or less comes to a more or less same. But the one thing is that like again, like coming back, if you want to manually manage the scaling and manually want to do this, it takes a lot of like effort on your side. At the same time, managing the cost will be entirely upon you. And I think rather if we try to automate this one, and through a load balancers and using again the containerization platform, which will able to manage that how I want to scale out, when I need to scale down based on the overall traffic load. If and all the clouds are providing all this kind of a services where you can it will automatically scale down when definitely the traffic load is less. So I think if we follow this kind of a proper design pattern, I think then definitely the cost is going to be minimized, right? But overall, like there is nothing called like you will get a higher cost in another cloud, and more or less it will remain same across most of the clouds that we normally see on day-to-day life.
Thank you, Tanmay. Kishore asks, if each microservice has its own database, then how many different types or instances of databases can be expected in the whole application, and how it affects the cost? Shubhra?
Okay, try to answer that one. Yes. So the concept that each microservices should have a separate database and how many instances, that's a very generic question overall, I will say. So what should happen that you don't need to have exactly separate databases for each type of thing, or you should not expect that, okay, you can have separate schema in the same database, or you can even have separate tables that one microservices is accessing two particular tables in the database, and actually at least they are editing and modifying only two tables. So you can put the constraint on that particular database that only these tables or these databases has to be accessed by these microservices. So in that case, you can reduce the cost. I have seen in my banking environment, not everything has a separate database. Yeah, we went with Postgres database a lot, where we have to, specific to that particular microservice, if we have some data that we have to store, we store in Postgres Postgres database to save that. But overall, the main database that we have, we separated the tables and decided that these tables will be accessed by these particular microservices. This is a way to reduce cost, and we did that because our same DB team was managing multiple databases and multiple schema, and it was easier for us to manage the cost that way.
Okay.
So that will be, yeah.
Thank you. Yeah, so I guess you use different schema names to identify groups of tables within the same databases?
Yes, yeah, I will say that one, because it's not possible to have a complete separate database for each one possible. You can have in the cloud environment, but with the banking, I know it's not possible given you have legacy databases and legacy application. So we have to come up with the way, and this was one of the way we came up with.
So it's more like an intermediate step before you get to that,
Yes.
maybe the ultimate stage where you have databases for things.
Correct.
Right. So I'm guessing these databases would also need to be domain specific, for example, customer data, data, and so on. And you're not going to have information spread between different databases.
Definitely, you have to separate data in some place that, okay, the data should not mix with microservices access which database. Should be there should be a separate data boundaries everywhere, but this is something that business and tech team has to sit down and decide themselves. And especially when the legacy database comes in picture, you have to come up with a intermediate solution before you're moving completely to a new solution. So it will be intermediate approach, and cost wise it will be a bit of cost saving.
Perfect. Thank you, Shubhra. The next question comes from Saurabh. He wants to know, considering its distributed nature of data across multiple services, how can we monitor data lineage?
Yeah, I think I'll take this, Ananta. This is a very good question, actually. So definitely, like when we data lineage and data provenance, I think these are the most important things that when we talk about, like data is flowing through multiple services, how we are tracking those things, right? So overall, if from my experience, when we design this kind of applications where multiple microservices are there and data are getting passed from one service to another, I think efficient logging mechanism is something that you need to, which will take what the data input is happening, and after like what the data change is happening, and you have to log it somewhere in a table, right? If you really care about, like, for each at a service level, you want to understand that how the data lineage is, that logging is going to be happen sometimes in the through the ELK. You can take that input or somewhere you can store it in the database also, that this is where the data is flowing through from layer to layer, and this is where the data is changing its. And I think it is also part of the how you do a audit monitoring, right? In terms of I designed something like that for one of those integration platform, because in integration platform, what happened, like it pulls the data from one system, it prepares the data based on the requirement from the destination system, right? So definitely the data has to be again massaged, and then has to be formatted, and then has to be changed so it fits the canonical model. So in terms of doing that, the overall audit mechanism was that when it is coming through one service, I'm taking a log of that one, like this is my input request. After that, when I'm sending the data like as an event to another microservice. There, if it is trying to do some query to a database and try to pull some data, again, I'm logging that one, that this is where, and if I'm formatting that one, then what is the final payload that is, I'm storing that payload as part of a table. So by that way, what is happening, like the overall data flow, I'm recording in a table as part of my audit log, and I'm able to monitor that how data has changed from the input to the destination system. I think that is how you can do the check the data lineage than the microservice.
Thanks, Tanmay. I think we're kind of close to time with the session today. I think we can just take one last question. This is to Deblina from Sanath. Can we have separate database connection pool for each client in a single microservice? and separate schema for each client?
I think, can I take this one?
Yes, please go ahead, Tanmay.
Yeah, I think, see, there is a certain challenge there. Means this is again a good question. So normally we use a JP or Hibernate to manage the database connections, right? What we had seen that if you want to connect to multiple database from a microservice, there is a normally there's a problem that happens because when Hibernate tries to manage this connections across multiple databases, it sometimes fails. So it's not actually something that is recommended that you connect a multiple DB through a microservice. Okay, rather you split it across two different microservices and you connect and you try to do our inter-services communication and pass that information to the microservice when you want to call from another DB or you want to query from the other DB and you do want to take an update on that DB. So that is the overall thought process. Don't try to do that with it because is my past experience, there's a definitely problem. It will allow you, but sometimes it gives a problem. Yeah.
Thank you. Right. Thank you everyone for joining for our conversation on microservices. I hope we've answered all the questions. I had to scroll up and down to make sure I get to every question. If it hasn't been responded, feel free to reach out to us. We'll be happy to respond to your questions. And I'd like to say thank you to the panelists, Deblina, Shubhra, Tanmay. Thank you for your time and responses to the questions from the audience today. Thank you, everyone. Have a great rest of the day.
Thank you.
Thanks.